Hello, I'm Steve Reyes, Product Manager for Anritsu. What we're going to show here is the way that we would normally typically mount our 220 gigahertz system, broadband system, ME7838G, onto a probe station. In this case, it's the MPI TS220 series probe station. So we'll go through some of the basic steps on how we mount the probes onto the modules and mount the modules onto the station. So it's mostly just a demonstration of the setup, and in other episodes we'll deal more with the calibration aspects of it. Okay, so to start off with, the VectorStar system has the VNA, which is a 70 gigahertz VNA with the appropriate millimeter wave modules and millimeter wave test set. The test set is very standard compared to our other broadband systems. So the 220 gigahertz system is not unique in the sense of the setup between the VNA and the test set as much as the uniqueness of the modules, the nonlinear transmission line modules. So the system is typically going to be set up behind the probe station, and normally you would want to elevate the test port of the VNA so that the cables have good access to where the modules are going to be mounted. And so the elevation of the system is your first consideration. And in this case, we had a system mounted on one of our synthesizers, which can often be used as a second source for things like mixer measurements or differential measurements. This particular system has internal two sources, and we can do active differential tuning, just using the internal sources. So in terms of the modules themselves, again, we have the MA25400A module, which operates up to 220 gigahertz. So the VNA is giving you the baseband frequency from 70 kilohertz up to 54 gigahertz. And then internally we have the sources that go from 54 gigahertz up to 220 gigahertz. And the upper end frequency is dependent on the model of module that you use. So we have 110 gigahertz modules, and we have 145 gigahertz modules. And the newest addition to the family is the MA25400A, going up to 220 gigahertz. Now, typically the test port on the module is going to interface with a probe. And how you mount the probe onto the module is a key aspect of the overall integrity of the measurement system. And typically you'll see a 1 millimeter connector for systems that go up to 110, 120 gigahertz. We have a 0.8 connector, 0.8 millimeter connector, that goes up to 145 gigahertz. Now, in order to get to 220, instead of designing another threaded connector, we decided to create an interface that would directly connect to the probe without using threads. And the way that we do that is using a UG387 flange, which is commonly used in waveguide types of measurement systems. And the UG387 therefore has the tolerances that allow connection up to 220 gigahertz with good repeatability. So what we use the flange for is to align the pins on the probe and on the module so that they create the mating interface, but without having to do the threading. The threads we found can wear and create some alignment issues after a period of time, and we're finding that the flange approach is providing much more repeatability. So that's what we're doing is connecting our probe onto the module using the flange interface. So the first question that would come up is, okay, how would I connect the probe onto this module? And sometimes what people do is they will mount the module onto the probe station and then connect the probe onto the module. And you can do that, and there are different ways that you might take that approach. I was going to show you a different approach when using the TS200 system. And the way that MPI has designed this system is that the bracket that mounts the module onto the positioner can be taken off. Okay, so we can bring out our module assembly out to the platen or on top of a position point where we can have easy access to the module. And then we take our probes and mount in this position. So we'll get our probes out, and these are 75 micron pitch probes, the T220 from MPI. And so you see that the probes are coming mounted on a mounting plate, and there's also a cover over the probes. And so we'll take that out and then start to prepare the probes ready for mounting. So here we have the T220 probe in this case, and so what we first do is remove it from the case, and then we can remove this mounting bracket from the probe just by disconnecting from here. Okay, so I mentioned about the center pin, and in this case it's a 0.6 millimeter airline coaxial interface. On the probe side, there is a male pin, and it has a slight protrusion from the base. And with these guides, you have some protection, but you do want to be aware of the fact that there is a positive pin depth to the male pin on the probe itself. On the module, the female is recessed in. Okay, and so you see that there are the two guides, and then we have this cover. So here we have the probe assembly with the protective covers on, and one way to prepare for mounting onto the module is first take off the top protective cover, since there is a top in the bottom half. Then what we can do is mount one of our screws onto the flange. Now we can take off the bottom cover. And so now we can mount the probe onto the module using the guide pins to help guide us in. And now that we have one of the screws already in place, we can quickly set that in very lightly, but at least it's there, and it's not going to be moved around because of the guide pins. We'll keep it aligned, and we can continue with mounting the other mounting screws. So I'll just go ahead and do that. just want to do it a little at a time on all four sides, just to make sure you get a good forward movement of the flange onto the module. And you want to double check that you don't have any gaps left over after tightening it down. Okay, once you get it just snug, then you can go to your torque wrench to be sure that you're equally torqued. There. And so now we have our probe mounted onto the module, and because of the assembly mechanism of this positioner bracket holder, we can then slide our module into place. And there's a set screw in the back that you want to tighten down. Now we can move this chuck out of the way and verify that the module is in the right position. And another aspect of this mounting scheme is that this whole positioner assembly can slide forward, and there's stops here to prevent it from going too far forward. And so what we can do is now verify the forward position is going to be in the correct place and position relative to the second module. So I can tighten that down, or I can leave it back out of the way when I'm not doing any probing. So for now, I'll just bring it back to create a little more clearance. So now I can start with mounting the other module. And again, it's just a matter of finding a place where you can work on the module while you're mounting the probe. So we'll get the second probe out. And again, remove the top cover first. And mount your top mounting screw. You don't want to go past the base plate. Okay, so now that we have our first top mounting screw pre-mounted, we can then take off the bottom assembly of the protectors and then put our probe onto our module. Slide it in with the guides, and then get our initial mount, and then work on the other screws to get those in place. And so movement of the probe is not having any effect on the center pin connection, since the guide pins are keeping it aligned. And again, just work it a little at a time on all four sides so that you're sure that the flanges are completely mated with no gaps on the edge. And then once we have it lightly tightened, then we can do our torquing. And the torque wrench is certainly a part of the accessory kit to help you with that. Same procedure, we just slide the base into the slots, tighten it down. And it's always good to have some sort of cable supports. That way you don't have any flexing of the cables while you're moving the probes around. And it just minimizes any kind of movement. And the same procedure here in terms of the sliding of the positioner on the bracket mounting assembly. There's a stop here as well. And so you can verify, that it goes to the proper position. And you can pull these back a little further just to be sure that you have plenty of clearance. Have it. Okay, so the chuck has ceramic chucks for the calibration substrates, which is always a good idea to use. And so now you've got your setup ready for calibration. And so that's the mounting procedure. And again, using this approach is helpful because you do have the ability to remove the module and position it in order to make the measurement or make the mounting of the probes off from above the chuck, and then you can mount that back in place. For other systems where maybe you don't quite have that accessibility, then what you would do is just back off your positioners far enough so that you can then work your way in, and having the covers can still give you some protection for that process. So that's the general overview on mounting the system onto the probe station. And in a following video, we'll show the calibration procedures. Okay, thank you.